Hey everyone, it's Friday, November 8th. The core team here's got some demos to show off, so let's get started. First up, we've got Stan, so go ahead, Stan.
Okay. Today I wanted to show how we can visualize some of the deephaven benchmark data in a deephaven UI dashboard. First, I thought I'd show a little bit how to actually make a run in an ad hoc way. And this run actually auto provisions a server, runs the tests, publishes data to our deephaven benchmark bucket, and then that data is available to the dashboard. Just as a little intro to just workflows in general, the deephaven workflow, the automated one, or the one that allows you to uh, auto provision a server, actually does two sides. So you can, in these sides, you can specify either an image version, you can specify a branch name with the user. So this could be run in a fork as well. A typical situation where developers for deephaven core would use this is they would uh, run their branch that they're considering merging on one side, and they would run deephaven main on the other side. In this demo, I'm just using the images because they're just faster and it's a little bit clearer. So these first two are those things. You can even put commit hash in there or tags. The set label prefix, that is a prefix that is used for storage, for accessing this data. So you're effectively naming this run something so that you can get to it later. The two branches or image names will be appended to the end of it, up to 20 characters. So in this demo, I did something like a demo release. The next field is some classes that you want to benchmark. These come from the standard benchmark package, and these are the classes, the test classes that run the benchmarks every night. One thing that about workflows is they're not consuming the data. They're really a start of the workflow, so they're pretty rudimentary. So if you want to know what the classes are, you have to look in the benchmark standard project, and you can look at the follow the readmes through on test writing, and you can see some of that. And in this first case, I did just an average star, which runs any test class that starts with average. And in this case, it's just average by. You can put commas in there and do multiple ones. Next field is benchmark iterations, how many times you want to run it. So it'll run the same amount of times for each branch or image that you have put in the top two fields. You got to be careful with this one. If you put too many in here, then it'll take forever, and you'll probably lose your server if it takes days. So in general, you have to be mindful of how long this takes. I did 11 iterations for this one, and I think it took maybe an hour and 20 minutes just for the average. And then the scale count, this is something that every standard benchmark is based off of, since different operations run at different speeds. You will have factors of this. So you may put 10 million in here, but you may have another operation that runs 6 times that. But the idea here is you can scale all of the benchmarks up and down with just one number. And just in case, like especially when you're testing benchmarks that you're developing, you probably want to run it at a lower scale just to see if it works. So in general, you shouldn't make that more than 10 million for this, because the server only has so much memory, and it will increase memory if you increase that. The last one is data distribution. You're going to want to use random most of the time. These other ones are interesting, but you're not going to get as consistent results. So you have to kind of know what you're expecting from ascending or descending or unlinked data for your operation. Then you hit run workflow. And one thing I'd point out about what shows up in the the workflow run list that you see in GitHub is that you can keep a little bit of track on where you are at. So I know you can't read this, but you can see two sides that look pretty much the same. Those are the two branches or images that are being compared. But if you click on the bigger one, each iteration is in a job. And so if you wanted to check, how is it doing? When's it going to be done? You can get a pretty good idea just by looking at the number of iterations you selected and where it's at, and whether it's in the second run or the first. Once that completes successfully, you should see, like I typed demo release in there. This is a view of the G Cloud bucket. You don't need to be able to see this in order to use the dashboard, but it's just to show you how the structure is. Actor is this name, secondary name under the bucket. Ad hoc is just a category. There's other things in here, but for the purposes of this demo, it's just the ad hoc that you would be running if you were a developer. And underneath, you see your prefix that you would put in there and the two sides appended to it. They're normalized to use underscores for this particular run, so it doesn't have the dots in for the version. And then underneath that, you will have multiple runs. The 11 runs that you did, they all have their own ID. And it just gives you an idea of the structure of the data. And then each one has some data that's collected in 3 files, the main one being the benchmark results file. And then if you want to access this, those are public URLs. So you can access it through HTTP. But here I have a demo of the deephaven UI dashboard. And if you remember, I said actor label, you got to remember those things. My actor was this. And I had started out with a label for the one set of that. Hit apply, it loads the data, and then you get some data. And this table on the left, upper left, is it's basically showing you the change in between each of those. There's different ways that this could be done with the 3, 5 in the front, but you have to recognize which one is the changes for. So basically, this is saying that if I sort based on, this is a regular deephaven table, so it has all of the features of that. And I want to know, hey, this was 9.5% faster in 3.5 than say it wasn't in 3.6. And so let's see. Over here in the other side, maybe you wonder why. It's not always code changes that make differences in rates. It could be the version of Java. So in this one, it's showing you that these tabs are showing you the difference between the two runs in terms of dependencies and some properties of the system, like Java or the operating system. So if it's not changed, it's not showing up. We have jar changes too, including the size of the lib directory for deephaven engine. And that's just showing differences as well. These are all the things that changed from the different versions. And then we have Python changes as well. These are the ones that if you went to the virtual environment that's used with deephaven, if you're running Python, you will see the site directory in there. And if you did a pip list, effectively what I'm showing in this list is the pip list and only the ones that changed. If you are curious about the actual runs in the benchmark run that you did, one thing to note is I did 11 runs for both sides for each of these, but you're only viewing one benchmark and 2 sides. So basically what you're getting is the median benchmark for each of these. If you click on it, you'll actually see all of the runs that happen for each of those data sets. So you can see, variability does show you something. So you can see down here, it's a little choppier than the one below. But if things aren't that bad, the chart's not really all that interesting. So we have this other workflow that we can do. And that means that this one means that you have an existing server that you can run benchmarks on over and over without it being checked in. So it's exactly the same hardware. And so you have a little bit more flexibility to do some other things like specify your own JVM options. And so what I had done with this run was I I just put 361 in there. And then for the first run, I used the default, which is just a 24 gigs and whatever deephaven delivers as the default. And then I just specified my own set label. The difference here is this is a set label, not a prefix. So you have to be careful if you want to use the dashboard for this data, that you've got the same prefix for data that you want to compare. And then this is this one allows you to specify the test package. This is the standard one where the nightly tests are run from. But if you were running in a fork, if you made your own tests, you could specify your own package there if you wanted to. And then here, I ended up running inline formulas. And I'm not going to run this; it takes too long. But another thing about this is if you use the same, if you do 2 runs and you use the same exact set label, it will put the results in the same directory. So one of the nice things about that is that, let's say you want to compare 2 things, and you could start out with just a few iterations on each side, and then when that's finished, you could run a lot more iterations into those same sets while you're working on visualizing what you have. So the rest of this is actually the same as what I described before. And so if you go back here, and that's the same, and that data turns out to be a bit bigger, so it takes a little longer to load. And so you get XX1 and XX2. So basically what I had done in this test was I specified, I did the defaults in XX1, and in XX2, the Java options that I changed were inline options. So I doubled the inline byte counts so that you could have bigger methods being inlined. I just want to see what happens. So turns out the XX1 with the default is quite a bit slower, and with these other options, it's there's a lot less variability. So you can kind of get something from that. Yeah, it's a bit faster, and the variability went very much down. But what the graph then shows you this time is a little bit more interesting, and that's that the data is clustered at the top of the graph, at the high performance side of the graph. We didn't get some mean in the middle. So that's a lot more informative than what we had before. But we can't just turn those options on for all tests, because down here with update view, which is a similar operation as what was in the top, the opposite is true. So you can see, do you really want to make that change? Is it something where if you do warm-ups before you do the update view, because maybe the JIT compiler was pushed off till later or something like that? But it does at least give you an idea of what's going on. And so there's more to come on that, but this is what we have for now, and that's it.
Very cool. It seems like it'll be useful for comparing across versions, and I like seeing people using deephaven UI.
Yeah.
And then next up will be me. Let me share my screen real quick. And okay, so I've got some changes for the web UI that'll be coming in version 37. So the big feature here is we've added the Ruff Python linter and formatter to our web UI. So this basically we started using Ruff internally a little bit, and we noticed they had a playground that had a JSON config, so we figured there must be some way to enable this in the web. And it turns out they are using WebAssembly to run their playground, but it was all published internally. So this is actually something we contributed back to Ruff, was publish actions for npm for their WebAssembly, because they are mostly publishing to Python stuff, so they weren't as familiar with this space. So this published Ruff to, oh, this is the wrong version. But basically, Ruff is now published to npm with several different bundles. And so then what we did is we consumed this in our web API. So this is zoomed in a bit just so you can see the text here. In the user settings, there is now an editor section. So this has a few different options. Format on save, which is using the Ruff formatter, which I believe just implements the same rules as the black formatter for Python. And then also the Ruff Python linter. So you can customize your Ruff settings here. We have a set of default settings that we think are useful. You can change the JSON here. You can also, it's got a link out to the Ruff settings doc so you can see how to configure these. And then there's also, Ruff has a list of all the rules that you configure. So I think there's like 900 something rules that you can configure if you want. So we have like some of these are entire rule sets, like I think this is PyFlakes rule set. It also lets you set things like if you there's only a couple formatting options, indent style and quote style, and then also indent width and maximum line length. So with that, so I have Ruff enabled here, and I'm just going to show a few examples of rules where I know we've been bitten by things in the past that we thought were like engine bugs, and it turns out it was a syntax bug that we didn't catch. So one example is starting in the middle here, I guess, is this T2. I've seen this before where we had an update and you passed two different update strings because you wanted to make an array, but it turns out that Python actually implicitly concatenates strings across lines. So this is equivalent to the explicit concatenation of those two strings, but these were intended to be different, and it caused our engine to fail to parse this because it makes no sense to concatenate these strings. So this is just one of the rules that's done by default. So it lets you know that you shouldn't implicitly concatenate multi-line strings. So you can basically saying you need to add a comma there that's missing. A few other things. So this second example here, this is letting you know that a function definition is using a loop variable that's not bound to that lambda. So this has caused an issue for us a couple times when writing components in deephaven.ui, and this is something that differs between JavaScript and Python, but basically this I variable here in Python ends up getting bound to the value 2, the end of this range, for all iterations of this function. So if you were to run this, you get the output 333 instead of 123. So what the fix is here that Ruff is highlighting is that you need to then bind I like this. So I equals I binds the value for each iteration into this lambda. There's a few other rules, like this is a unnecessary list comprehension, and for certain rules, if there are quick fixes in Ruff, they're available. So I can say rewrite, this is rewrite using list constructor syntax, and then we also have highlighting unused imports. So since Ruff is this is being done all on the client, Ruff statically analyzes single files, so it's not going to tell you that an import doesn't exist because it doesn't know the whole module tree on the back end, but it'll tell you when things are unused, at least within your notebook. And so let's say you are fine with leaving this. There's also quick fixes to disable rules for a specific line or for a specific file. So if I say disable for line, it adds this comment for me to disable that rule. Or I could say, I want to disable it for the whole file. That adds it up to the top, so it won't warn me about missing imports anymore. And then the last thing about the linter is it also applies to the console, but for the console, it's only going to show syntax errors. So if I had, a print statement with an extra parentheses, I get a syntax error here. Ruff actually reports multiple errors in multiple ranges here, but there's the rest of the formatting rule or linting rules are not applied to the console because we found it was actually quite annoying since it again does only lints based on this document. It doesn't know the history of what you've run. And then finally is the formatting. So there's multiple ways to format. So if you have the format on save option checked here like I do, then whenever I save this file, either with Control S or clicking the save button, you'll see it automatically formats for me. So I can undo that, and you can see that it took this long line that had weirdly broken up parameters, and it took this that's only indented to 3 spaces instead of 4, and fix those. It'll fix your quotes when it can and everything like that. Um, and then if you don't like format on save, you can also manually format with the overflow menu here. It's also in the context menu, and the context menu shows there's also a keyboard shortcut to format. And that is it for me. So I think that's it for this week. Let me find OBS and finish this out.